The topic of this lecture was the infinite, a traditional philosophical topic. In the first part of the lecture, the calculus helped us to avoid drawing the wrong philosophical conclusions from Zeno's paradox of infinity, a philosophical argument that was meant to undermine the appearance of change. In the second part of the lecture, we found a way of avoiding Galileo's paradox of infinity without restricting the notion of size just to finite sets. Modern set theory supplied us with an exact, fruitful, and simple concept of size that generalizes the concept of size of finite sets. On its basis, we were able to define a concept of infinity that is equally simple and illuminating, and in terms of which one can prove that there is not just the infinite, but there are actually different sizes of infinity, and indeed, infinitely many of them. Let me wrap up this lecture with a couple of observations. First of all, here's a worry. What we've been doing here isn't really philosophy anymore. This is mathematics. Well, Zeno's paradox certainly is regarded as philosophy. The calculus was only a method of testing the plausibility of certain premises in Zeno's argument. As far as the second part of this lecture is concerned, it is only important to keep in mind that the question, what is the infinite, is a classical philosophical question. And it is hard to doubt that set theory has led to enormous progress on that question. How one ought to draw the borderline between foundations of mathematics on the one hand and philosophy on the other is a question that I will simply put to one side here. Secondly, a different kind of worry. In some parts of the talk, I was using mathematics, but how do we justify mathematics in the first place? More particularly, how do we justify it philosophically? For instance, in some parts of the talk, I presupposed the existence of the natural numbers. But what do we mean by that? On what grounds are we allowed to do so? Should we really believe in the existence of infinitely many numbers? And shouldn't philosophers worry about that? The answer is absolutely. There is a whole area of philosophy that deals with just these questions. The philosophy of mathematics. I'm very much interested in that area myself. It is just that it was not the topic of today's lecture. Also, there is nothing wrong about using mathematical methods in one part of philosophy and questioning these mathematical methods in another. It's like there is nothing wrong about using traditional philosophical methods, such as conducting thought experiments, in one part of philosophy and questioning these philosophical methods in another. I should also emphasize that the definition of infinity that we ended up with did not refer to the natural numbers in any way. It only involved logical or quasi-logical notions. And the definition did not entail the existence of infinitely many objects either. It merely determined a concept. That's all. Thirdly, what happened to our initial worry that finite beings, such as maybe ourselves, are not in the position to understand infinity? To some extent, we found this to be unjustified. We can talk about infinitely many objects, such as the natural numbers, and also sets of infinitely many objects, and we do so in finite terms. We are able to define infinity in finite terms. In set theory, we prove the existence of infinite sets of different sizes in finite terms, and so on. We need to be careful, of course, to avoid being stuck with paradoxes. And of course, it would be ridiculous to think that what we've gained is anything like a complete understanding of the infinite, whatever that might be. But we did gain some understanding of some aspects of the infinite. And mathematics was crucial for that. Actually, things might be just the other way around. As much as we are finite beings, it might be easier for us to understand the infinite than the finite. Think of our definition from before. We defined infinity of sets, and then we defined finiteness as non-infinity. So it is finiteness that is defined negatively, as the non-existence of a pairing off with a proper subset. Perhaps we are beings whose understanding of the infinite is prior to their understanding of the finite. Fourthly, you might think that we are taking away everything that was mystical about the infinite by approaching it in a precise, systematic, and rational manner. And isn't that a pity? Well, to the extent that we do, that's just the way it is. Philosophy does aim to conceptualize and rationally reconstruct what might have seemed incomprehensible beforehand. But there is not much of a worry that a lecture like this would dissolve the mystique completely. For instance, modern set theorists believe, with Cantor, that if all the transfinite cardinal numbers, all the numbers that measure the sizes of infinite sets, are taken together, then it is so many of them that they do not form a set anymore. It's simply too many of them. As Cantor said, they form an absolute infinity, an infinity that is greater than all transfinite cardinal numbers, an infinity whose size, therefore, cannot be measured anymore in set theoretic terms. If this absolutely infinite is not mystical, what is?